So today we'll be solving question number 10 from exercise 2.1 of the book Challenges and Thrills of Pre-College Mathematics. So the question says that we need to prove that 2 into 7 power n plus 3 into 5 power n minus 5 is divisible by 24 for all positive integers n, which is essentially all natural numbers n. So again, we'll be proving this by induction. So let's take the base case. So the base case will be n equal to 1 since it's the smallest positive integer. So we have 2 into 7 power 1 plus 3 into 5 power 1 minus 5. It's equal to 14 plus 15 minus 5, which is equal to 24. Now obviously 24 is divisible by 24, so the base case satisfies. Next, for the induction hypothesis, let's say that okay, I will write some notation here. Say that 24 divides, this symbol is divides, so 24 divides 2 into 7 power n plus 3 into 5 power n minus 5 for all n less than equal to k, right? So since it satisfies for all n less than equal to k, it must satisfy for k as well. So 24 divides 2 into 7 power k plus 3 into 5 power k minus 5, right? So essentially what this means is we can write 2 into 7 power k plus 3 into 5 power k minus 5 as 24m, where m is an integer, right? Because this essentially is divisible by 24, so when you divide by 24 you must get an integer. So we have this. For the inductive step, what we will need to prove is that 2 to the power 7k 2 into 7 to the power k plus 1 plus 3 into 5 to the power k plus 1 minus 5 must be equal to 24 to the power l for some l belonging to integer, right? So if we expand this, essentially what we get is 2 into 7 power k into 7, right, plus 3 into 5 power k into 5 minus 5, right, must be equal to 24l, or let's just remove that part for now. Let's just work on the LHS, right? So we have this is essentially 2 to the power 7 2 into 7 to the power k plus 6 into 2 into 7 to the power k, because essentially the motivation for this splitting is that we want to somehow use the previous expression, the previous equation, this equation essentially, in the inductive step, right? So we're trying to take this out. So we have 2 into 7 to the power k plus 6 into 2 into 7 power k, plus again we try to take this out, so 3 into 5 power k plus whatever is remaining, so 4 into 3 into 5 power k and then minus 5, right? So now we know that this and this together is essentially 24m, right? So what we can do is we can write that this is 24m, and then the remaining parts are plus 6 into 2 7 power k plus 4 into 3 into 5 power k, right? This is essentially equal to equal to equal to equal to, right? Yeah, this is essentially 24m plus 12 into 7 power k plus 5 per k, right? So we got this. Now note that 7 per k will always be odd and 5 per k will always be odd. So we can say that um, essentially that since 7 per k is odd and 5 per k is also odd, 7 per k plus 5 per k will be even. So we can write it as 7 per k plus 5 per k. We can write it as let's say 2p, right? Because it's even. So we have equal to 24m plus 12 into 2p, which is equal to 24m plus 24p, which is equal to 24m plus p. And since p is an integer and m is an integer, we can take m plus p to be equal to l. So we can write this as 24l, right? So essentially we have proved that this statement, this part of the expression, 2 into 7 power k plus 1 plus 3 into 5 power k plus 1 minus 5 is equal to 24l for some integer l, since m is an integer and since p is an integer. Since we proved the inductive step by principle of mathematical induction, this is true for all n natural numbers.